Hello, everyone. Today we're going to be giving you some information on the 30s. The big thing that we are adding today is the variable n. N refers to moles. So we're going to be using n for moles today as a symbol because a lot of the other symbols were actually used up throughout science. So we're going to go through this page and fill it out as we're going along. And then I'll let you do some problems on your own. It says the Kelvin temperature triples, then the molecules are moving faster. So if we give molecules more energy, they will move faster. As the faster moving molecules hit the sides of the container more often and with greater force, the pressure would triple. And that would be for a container that the sides cannot move. So this would not be a balloon. This would be a glass container or a steel drum or something like that, a steel scuba tank. But if the container could in fact expand like a balloon and the pressure didn't change, the volume would change in that place. So then the next one, it says the pressure and volume are inversely proportional. They are one of the two that are actually opposites of each other. Oh, forgot an E there. They are opposites of each other. So if external pressure goes up, then the volume would decrease. So think about squeezing a balloon from the outside. If you're squeezing on the outside, then that internal volume would get smaller. Think of a capped syringe. If you increase the pressure on that syringe, that internal volume would go down. This only works with the Kelvin scale. One, because there is no negative numbers in the Kelvin scale. But this is also equal to the average kinetic energy. So with the Celsius scale, with the negative temperatures that exist on that, you could end up getting negative volumes, and you really can't have a negative volume. If the Kelvin temperature triples, then the moles mathematically would be divided by 3, since temperature and moles are inversely proportional. So there are two that are opposites of each other, two that are inversely proportional. It's pressure and volume, and then it is temperature and moles. Those are the only two that are opposites or inversely proportional of each other. All the rest of the variables are directly proportional to each other. It means if one goes up, the other one goes up. Kelvin temperatures and moles must be inversely proportional. This is a mathematical situation. So mathematically, they are opposites of each other, or they are inversely proportional to each other. Strictly by math, that's how it was figured out. This relationship is used for many factor label problems. Temperature and moles are inversely proportional. Pressure and volume are inversely proportional, and all the other relationships are directly proportional. So there's everything that we just went over. Pause the video if you need to write all that stuff down in case you did not get it the first time. And remember, as we're going through, you can pause the video at any point in time. All right, so we're going to work with our first problem that we are going to have moles involved. So I take a look at this problem, and I am looking for a label that does not have a partner. So I have K here, millimeters of mercury. I have moles and moles. And so the one that does not have a partner is my temperature, and that's 384.2 Kelvin. So the one that does not have a partner, that is the one that you will be starting these problems with. I put a multiplication sign and a division bar, and the two variables that I do have that are changing, I have pressure changing and I have moles changing, and it really doesn't matter which one you start with. I'm going to just start with moles so we can do that one right away. So moles and temperature, those are our two variables, and we have our moles going from 12.0 moles up to 24.0 moles. So our moles are increasing. If our moles increase, then our temperature must decrease. And again, they found that mathematically, that is pretty much the only way that they could figure it out. So if the moles are going up, the temperature must go down. So I arranged these two numbers to make my temperature get smaller. So if I want my answer to get smaller, I put the smaller number on top. If you want your answer to get bigger, you put the bigger number on top. So moles are taken care of. The next one is pressure. So we are going from 888.88 millimeters of mercury. We're taking that to 222.22 millimeters of mercury. So in this problem, our pressure is going down. And how does that relate to temperature? If pressure goes down, then temperature must go down. So I arrange these two numbers to get my answer to be smaller. So I put the smaller of the two numbers on top. All right, so again, we're going to repeat that. Over in this step right here, I want my temperature to get smaller, so I put the smaller of the two numbers on top. Over here, I want my temperature to get smaller, so I put the smaller of the two numbers on top. When I go through this, these labels cancel each other, these labels cancel each other, and I'm going to be left with my answer in Kelvin, and that is exactly what I want. I want a new Kelvin temperature. So if you punch all of that information into your calculator, you end up getting 48.0 Kelvin. Sig fig wise, this is 3 sig figs, this is 3 sig figs, this is 4, and this is 5. So our answer should have 3 sig figs, and that is our answer. I'll give you a prettier version here. Again, if you need to stop the video and write some stuff down, you can absolutely do it. You can see in this version that I did the moles over on this side, and I did the pressure over on this side. It makes absolutely no difference whatsoever. You can see I did this part. You can see I did this part. So that's where our 3 points would come from. So I'm always stating what's occurring, then doing my arrows, and then finally arranging the numbers. So that's how you do a problem with moles in it. So what would be the last answer in Celsius? So going back to that skill of converting numbers between Celsius and the Kelvin temperature. So that is our overall formula. And so what I need to do is I need to get Celsius all by itself on that side. So I subtract the 273.15 from that side, and I end up getting this. I pop in my numbers. Following the sig fig rules, this one only goes to the tenths place, so my answer should only go to the tenths place, and I end up getting my answer as it is. So moles are kind of weird as far as putting them into a mathematical problem, but if you treat them like any other variable, everything should work out just fine. The rest of this is homework. Check your answers as you need to. Ask for help as you need to. Have a good day.